Welcome back to next session, debugging ASP.NET Hang or slow response. Throughout the previous lessons, we have found out how to capture dumps, how to look at you know the process or the request, whether it's slow in Fiddler, and then capture a manual hang dump. We also familiarized how to run commands in WinDBG and get the output. So in this one, we are going to use all those knowledge to find out the slow performance, reason for slow performance. So this is a scenario where our featured products.aspx page in our buggy bit application was taking time, 5 seconds when we actually browse it alone, and then if we get a number of requests, we are seeing 200 plus seconds is taking. So let's see what is the first step to do it. So we have already done this. Let's go to our first dump. So I have opened the dump with the first dump which is captured. So we have captured three sets of dump with an interval of 10 to 15 second, intervals. So the first and foremost thing we can actually do is you can do star tilde star k. It will just list all the commands. So in this one, I'm having an application which is running in .NET Framework 2.0, and what we actually need is um, the all the stack output and analyze the stack, the first and the foremost thing. So if you look closely, you see a lot of threads. So we have a command just to see what the threads. We have like 37 threads running in this. So if you see that you have so many threads in this, so what are these threads? Why do we have to understand what is this thread? So the thing about it is we can ignore a lot of these threads. So in this slide I have given examples of stacks which you can ignore. So we mainly see four types of threads actually in a dump: CLR threads, W3WP threads, RPC threads, and other COM threads. The CLR thread can be of CLR, the GC, or it can be of the managed thread. So when I say CLR thread, it's again every thread is basically native, but some thread would also run your C# or VB.NET code. We call those threads managed threads. So CLR threads, there are threads which is allocate, which is GC or timer threads and stuff like that, which is actually not running your managed code, but runs CLR code. And then we have W3WP, which is the host process which our IIS website runs. And then we will have RPC threads and other COM threads. So the first thing is you would actually see before looking at any stack is that these four functions, there are other functions also, but I just summarize mainly main four functions. You would see on the top of the stack NTDLL, NT wait for single object or NT wait for multiple objects, and remove IO completion or wait for work via worker factory. So these functions, basically when you see top of these functions, that thread is not really doing anything at that point of time. It simply waits for a signal or simply waits for um, a notification to have come back, and then only the thread will come back, wake up, and then do something. So when you see something like this in the stack, on the top of the stack, that means that thread is just waiting for a signal, or it's basically asynchronous primitives. You don't really have to understand the details of it, but if you really want to know, you can just Google or Bing this function names and you will understand more about it. So this, when you see this thread is basically W3WP main thread which initialized the application host. So you don't really have to do anything about this because this has nothing to do with our request. This is which IIS require. And then we have native RD notification thread. So this thread is native RD is DLL which is used for anything related to our configuration schema, reading and writing, and configuration stuff. So IIS uses this thread to get any changes in notification if somebody changes this, config file or something, and then it'll automatically do the updating and recycling and all those kind of things. Okay, so this also we can ignore, and you see that on top if we have remove IO completion, this is basically worked on IO completion model. And then this is a worker thread again on the top of this. This will be used whenever any work is required by from in the process, but this at this point it will not, it's not really using, or it's really used because it's simply waiting. Okay, so we can ignore many of these threads. And this thread, which is thread pool data, which W3 has its own thread pool mechanism, and when a request comes, a thread pool thread actually goes and then gets a request and passes it to ASP.NET and stuff like that. So we will get to the details of that later when we actually go through the architecture or the internal process mechanism of WWP. But you just have to understand this, that there would be threads like thread pool threads, which is idle, sitting idle in the application in our process. So coming back to a slide, so this is the main thread which is used for shutdown, and then this is another thread which is which we saw read write notification, and then the idle worker threads, you see that TPP worker thread, and then it wait for call at the top. Okay, and then the ideal thread pool thread which we saw, we have this thread pool data, so you can ignore these threads. And then now we have so many threads like this. The thread pool thread will be many multiple threads, the worker threads will be multiple threads, and then you will see something called IIS frab is IIS failed request manager thread. This also you can ignore, which does not really do anything in the process. It's basically used by IIS whenever you enable a logging called failed request tracing in your IIS. It will use this thread to write that log to the file system wherever path you mentioned. So this is actually not at all used at this point. So these threads are just there's a thread sitting in our process. So we will find many threads for IIS fastGA also, which is again worker thread, which will not be used. If you have a fastGA module installed, you will see these threads. Now you would see, then you will see something like this: MS Core Works DLL. So this guy basically is MS Core Works. We have seen in previous video or lesson that we have two DLLs mainly, CLR.dll or MScore WKS.dll. MScore WKS.dll is used by .NET Framework 2.0, or it's when you say .NET Framework, this is where everything is implemented. So MS Core Works has a lot of functions implemented, which is what is actual our hosting our CLR, or the our entire virtual machine setup and all these details in of CLR. So MSCO works, or CLR, if this was a dump of 4.0, you would see that. So I have a dump of 4.0 open here, and I can show you the same thing there. So here you would see many CLR related call, and these CLR is basically, in case of 2.0 you would see MS Core Works, and in case of .NET Framework 4 you would see CLR. So this is, we saw this failed request module trace, ideal fast CGI, ideal CLR. So CLR, this is a completion part thread of CLR, and you would see if this is 4.0 you would see this, or if it's MS Core Works you would see something like this. Okay, so that is about the idle threads. You can actually ignore many of these idle threads. And let's come back to, okay, so I'll explain about these assembly threads later, but here but you can ignore these also. Okay, as of now it's uh, yeah, these threads you can ignore for now. As of now we are actually here. Okay, so in this one, what we see is we are in get featured products, and then um, so let me get the stack once again, because what you see here is sometimes the stack cannot you know um, resolve the symbol, so it will just give some errors like this is only the first time, but if you run the command again it will go away. But you can ignore these errors, which basically says unable to verify checksum. This can happen if it's a .NET DLL, but you can ignore this. So thread 26 has wait for multiple objects. It's but if you look closely, this also runs our .NET code system.web ni, and it also has some functions related to our get featured products. Okay, so now if we go back, we see other threads which is doing something similar like that. Okay, page load, page load. So going back to our slides, now let's go back to the dump of list. Okay, okay. So this is a 4.0. I'm going to show you the 4.01. Um, More or less the same, just that the ideal threads and the call stack would be different. So in this one, if you ignore all the ideal threads which we have mentioned in this guy, so we have GC thread which will have something like GC CLR GC Zero GC, which at this point it's just there. GC is not happening. You will see as many number of GC threads as the number of cores you have. So if you have a 4 core machine, you would find 4 GC threads like this. If it's actually hyper-threaded, then you would find eight threads like GC threads like that. So that's the way of CLR works. The number of GC threads would be the number of cores, and then we'll have a one finalizer thread. You would see a finalizer thread start, but it is not doing anything. It's just when GC starts, all these threads would start happening. So this is one example of we can actually identify what this function does. Basically, it waits for the signal, and then this is internal mechanism of how GC implemented. It waits for the signal, and then it notifies this thread, and every other thread will be freezed, and these threads finalizer, if finalizer is running, this thread will do the work, and it will keep on running. So that's how it works. So we have a scenario which explains how a finalizer can cause problems in your application. So then you will understand more about this. So that's, but as of now, you can ignore for this scenario which we are working. You can ignore this, and we have a profiler thread also, you would see, which you can ignore. Okay, it will wait for a profiler to be attached, and then we have a timer thread. So any timer operation which you do in your CLR, it internally uses this timer thread. So this again an idle thread which you can ignore, and there will be an app domain thread which basically waits for the app domain unload, and this we already saw. And I have given a couple of references in the slide. You can actually refer this for 2.0 and 4.0. You can refer this, and you will find that many of the stacks which you can ignore. But our most important, coming back to our important stuff, after all those stuff, but you would see what we are looking for is we are looking for our code, the code which is executing ASP.NET. So that means our ASP.NET is basically system.webassembly, and system.webassembly you would see something like process request notification. Okay, and you would actually see the page system.ui.page process request. This is where our actual request execution happens. So when a request comes, first IIS will get the request, and then it pass it over to the .NET runtime basically, and then that invokes our handlers, and then it internally invokes the process request. So this is actually the normal flow, but what we have to look for is this guy which is basically executing our code. So you see that we have many functions, many threads which are actually doing get featured projects. Basically featured products.aspx is what we have made a request to. So you would see many requests this. How can we avoid this? So this basically shows the stack which is which shows both the native stack as .NET stack. So how can we actually go back to only what we see? Enter the .NET stack. This is the important thing which we did in a previous analysis or previous commands which we familiarize. So all you have to do is tilde star e, and you can do bang CLR stack. It will go through all the threads. If this thread 37 thread is a CLR thread, it will dump the stack, otherwise it will not. So basically a couple of things you would see that it's not dumping anything, but other threads is dumping. So this is what our ASP.NET threads or ASP.NET requests are doing at that point of time when we capture the dump. Okay, so now we have, so many threads are native threads, so it will not really show anything. If you go to the start of our command, you see it started from here, and you can see that many of these threads it could not dump it or show the CLR flag because all of those native threads like CLR idle thread or WWB work approved threads. But here is what our stuff is. So we see that featured products, it's on page load, the default.aspx page, sorry, the featured products.aspx page, it's on page load, and it's calling data layer.get featured products. Okay, and then we go to next dump. So normally this would be your application or your application written by your team. So you would actually see functions in your application or data layer which basically waits for it. So this thread is executing something. Say it's executing get featured products. Okay, then the next thread is also executing get featured products, and next one is also. But if you see, look at this, you see a stack almost as similar. Basically, after get featured products, you see monitor dot enter, and you see the same in the next one. You see the same in the next one. You see the same in the next one. Next one, almost same. But in this one, you see something different. We are seeing a sleep call, okay, and then sleep internal. But only other than that, every other thread is actually doing, a get featured products and is basically on system.threading.monitor.enter. So we will get to the details of what is this monitor.enter. But before that, so now we see a lot of threads. So in your application, it would be something. You may be calling a web service. You may be calling a database operation directly. It may be executing a SQL command. So maybe that is taking time. But how do we identify? We are troubleshooting a performance issue. Say this request took 200 seconds or 50 seconds. How do we identify that this particular thread is executing for this long time? So for that, that is why I have requested you to capture three sets of dumps within three different intervals. And to help you from a perspective of how long the request is running, we have to utilize the dump, an extension called PSS score 2, okay, in case of ASP.NET 2.0, and ASP.NET 4.0 we will use PSS score 4, and in case of 4.5 or above we will be using netext is another command. So all you have to do is you can run a command called aspx. So let me load PSS score first. 2. Okay, let me check if this is the 4.0 dump. Okay, I think we have to first I will show you the netext one. Okay, so dot load netext. Okay, I have loaded netext, and now if I do whttp, okay, before that you have to run index first. So it will tell you how long these requests were running. Can you see that? If you go here, so many of these requests, basically what this does is, this command goes to our .NET heap, dumps all the HTTP context objects. So HTTP context objects has details like how long this is running and whether the request is finished or not. If you see, it's still running, but this request is finished with the 200 status, but you see that it's running for 12 seconds, and this is actually 12 minutes, and here in this one we see that it's running for 38 seconds, and here another one which is 13 second. Now we have commands. One more thing which you can see is you have the thread ID. So thread 32 is executing featured products.aspx for 33 seconds. Now let's go to thread 32. How do we do that? We switch the context and then you do CLR stack. You can see that for 32 seconds we are in get featured products. At the 32nd second we are at get feature, but we don't know before that what this thread was doing. Okay, so what we have, that's why we have the next dump. So in this dump is collected at 12 11 13. Okay, so you see the timestamp here. If you see the timestamp here in the dump, if you capture it using WinDBG, you would get the local timestamp like this. Okay, so basically it says that at 12 11 13 we have captured the dump. Now let's go to the next dump, which is 12 11 37. I have one dump, and 12 11 40. So let me go to 12 11 37. Excuse me. And if I expand this, you can see that it's a 12 11 37. So this is at the 37 second. Okay, now we will load the same net.ext, and we will first index. Okay, we'll just first w index, and we will do whttp. Okay, it will show you all the threads, and in this one, if you look at it, the thread 32 is executing feature.aspx for 57 seconds. That means this is 37, and previous one was at 13. So we have that time difference. We see that 32 is still doing the same thing with 57 seconds. Now let's go to 37 and look at CLR stack. Sorry, I this is 32. Sorry, this is 32. Okay, so I switched to the wrong one. 32s, and okay, now we know that that particular request, get featured request, is in get featured products call for whatever time difference which we see in the dump. That means that thread is not doing something. That means the delay is in this function, get featured data layer dot get featured products. So you can do this for other requests and check if you see the same pattern. We already saw that most of the calls are on get featured products. So this is one way to drill down to the method which is causing the problem in our application. So in our application, it may be a DB call, or it may be a call to an external web service. It may be a custom call which we are making, to do some processing. It can be anything. So this is the way consecutive dumps. We get the stack, which we get the request using WHTTP in case of .NET Framework 4.0, and then you have to match the request and the timestamp and the thread, and figure out what that thread is doing. Okay, so now we have identified that this function is taking time, and this is the cause of featured products page to have a delay of 5 seconds to say 200 plus seconds. So if large number of requests comes, the delay increases. So now we have this is the way we have identified that this guy is again making a call to system.monitor.enter, and that we will actually see why it's doing that. So we identified in a 4.5 or 4.6 term we use netext's HTTP command. In case of .NET Framework 2.0, we can run the same command, but we also have a similar feature in PSS core, PSS core 2.dll. In case of .NET Framework 2.0, the command name is called bang aspx pages. If you just run bang aspx pages, it will give you the same detail. It will give you the thread ID, and so the thread ID is basically this guy 35 or 32, and how long it's running, so 35 seconds. So this is another the same thing which we do in a 2.0 application. So what you have to do is you have to get this output, and then run that output in all the three consecutive dumps you've taken. That is the reason why we have to run the get the consecutive dumps and compare the output and figure out what the thread is doing for how long. So if you have collected one dump, you will not be able to conclusively say that this method is running for that long. The reason is when you collected the dump, at that time it is actually in this function, but we don't know what it was doing, what page load was doing before. So they say page load has another call which say this request was taking say 30 seconds, and we have got the dump at the 29th second, and um, till 25th second say page load was doing something else. You will not really get that in the dump which you have taken 29. So that is why to confirm things, consecutive dumps are mandatory for troubleshooting high performance issues in your ASP.NET application. Okay, so now we have identified that this is causing the problem, and now this is a way you drill down, whether it's a database call or web service call. You have to do this comparison in your dumps when you capture the memory dumps and then take it forward, isolate to this one. So now we have identified that this is the function which is causing problem. In the next video I will explain some concepts about how this is causing or what this call is doing. But to conclude in this one, so basically in this call get featured products, we are using a lock mechanism, synchronization mechanism, and all the threads which is requests are trying to enter that lock, but one which is actually is already has that lock is making a sleep call, and that is causing the problem. Or in a real application that would be database call or web service call or something like that. So problem is one thread which has a lock, every other thread is right trying to get that lock, but the one thread which has a lock is consuming some time, which is causing all the other threads to wait for what one particular thread, which is causing the entire application to slow down. So that is what is happening, and you have the source code of this in you have the DLL of this in your setup in your environment. So go have a look at this function and how you know try to identify more about this. So in the next video I would explain more about synchronization primitives and how we can run certain commands to figure out who is holding the log and how we can take forward, and I'll also show you from the dump itself how we can look at the source code of this function and dig deeper and understand what the application developer or the developer has written to do things in the code in the application. So please open the dump, open this, do the same procedure. Once you try this, then only you will understand this. So please do that and then only go to the next video. Thank you.